Reactivity of aldehydes and ketones. This is today's lesson. We have three compounds here. Those are methanol, ethanol and propanol. Let's write the names of these compounds. Methanol. This is ethanol. And this is propanol. In this lesson, we are going to learn from these three compounds which one is more reactive and why. So let's go to the detail. First of all, let's try to learn what are carbonyl compounds. Let's see. This is functional group of aldehyde. When this hand is satisfied with hydrogen or alkyl group or aryl group, then the compound formed will be aldehyde. Let's see what are ketones. This is the functional group of ketones. When these two hands are satisfied with alkyl group or aryl group, then the compounds formed will be ketones. Here one thing is observed, that both aldehydes and ketones contain a common structure, that is CO group. This CO group is known as carbonyl group, and the compounds, that is carbonyl group containing compounds, that is aldehydes and ketones together, called carbonyl compounds. So these three compounds are carbonyl compounds. These two compounds are aldehydes and this is ketone. From these three compounds, which one is more reactive? Let's try to determine. One point is here: carbonyl compounds undergo nucleophilic addition, not electrophilic addition. Let's see what is the reason behind this. Let's write a carbonyl compound. For example, this propanol. It undergoes nucleophilic addition, not electrophilic addition. Here we see there is a carbonyl group, carbon-oxygen double bond. Here oxygen is more electronegative atom. Its electronegativity is 3.5. On the other hand, electronegativity of carbon is 2.5. So there is a difference in electronegativity between these two elements. That is why these pi electrons move towards oxygen, and as a result oxygen gets negatively charged and carbon gets positively charged. Now this compound is suitable to react with both electrophile and nucleophile. Electrophile may combine with this oxygen and nucleophile may combine with this carbon. But it is said carbonyl compounds undergo nucleophilic addition, not electrophilic addition, because in the first step nucleophile bonds to positively charged carbonyl carbon, and in the second step electrophile combines with negatively charged carbonyl oxygen, because here electronegativity of oxygen is very high. That is why at the first step oxygen doesn't donate electrons to electrophile. That is why electrophile cannot combine with oxygen because of the higher electronegativity of oxygen. Oxygen doesn't donate electrons to electrophile. But at the first step, nucleophile combines with carbon very easily, and after that this oxygen becomes fully negatively charged from the partially negatively charged, and then electrophile combines with this oxygen, and oxygen now donates electrons to electrophile easily. So in the first step, nucleophile combines with positively charged carbonyl carbon. That is why it is said that carbonyl compounds undergo nucleophilic addition, not electrophilic addition, because of the higher electronegativity of oxygen. Oxygen is not willing to donate electrons to electrophile in the first step, but in the second step, over the oxygen, electron density increases because carbon bonds to nucleophile. Then over oxygen, electron density increases. That is why this oxygen now can donate electrons to electrophile. That is why it is said that carbonyl compounds undergo nucleophilic addition reaction. Let's move on to the next point. Now the point is reactivity concept and reactive compound from these three compounds. Let's see. Let's consider a carbonyl compound. That is ketone. We learned that carbonyl compounds undergo nucleophilic addition reaction. That is, nucleophile bonds to positively charged carbonyl carbon. Oxygen gets negatively charged, carbon gets positively charged, and this nucleophile combines with this positively charged carbonyl carbon. Here reactivity concept is, the more the charge density of this carbonyl carbon, the compound will be more reactive. That is, this is suppose carbonyl carbon. Here charge density is more, the carbonyl compound will be more reactive. If it is less in density, it will be less reactive. That is, the interaction between nucleophile and positively charged carbonyl carbon depends on the charge density of carbonyl carbon. The more the charge density, it will interact with nucleophile strongly. If the charge density is less, it will interact with nucleophile with less interest. This is about reactivity concept. The more the charge density, the compound will be more reactive. Now let's see in which compound carbonyl carbon is with high charge density. Let's see. Methanol. Here we see in two hands of carbonyl group there are two hydrogen atoms, but in ethanol, in one hand hydrogen and in the other hand methyl group. In propanone, in two hands of carbonyl group there are two methyl groups. Here we see two hydrogen atoms, and this carbonyl group is polarized in this way, it becomes negatively charged, carbon becomes positively charged. Here, in the same fashion, this oxygen gets negatively charged, this carbon gets positively charged. In the same way, this bond is polarized, oxygen gets negatively charged, carbon gets positively charged. But here we see there are two methyl groups. We know that methyl group is a kind of electron donating group. Electronegativity of carbon is 2.5 and hydrogen is 2.1. Because of the slight high electronegativity of carbon than hydrogen, these covalently bonded electrons move towards carbon because of its higher electronegativity slightly. And this is the carbon which do not possess high nuclear capacity to hold these additional electrons. That is why methyl group readily pushes towards the neighboring atom. So simply we can say that methyl group is a kind of electron donating group. So here there are two electron donating groups, methyl groups. These are donating electrons to positively charged carbonyl carbon. That is why the charge density over carbonyl carbon is decreased. Here there is one methyl group, electron donating group. So it donates electron towards positively charged carbonyl carbon. So its positivity decreases as well. But here there are two hydrogen atoms, no methyl groups. That is why in this case positive charge over carbonyl carbon is not decreased. That is, we can say that this is the positively charged carbonyl carbon. Charge density is very high. Here one methyl group, its charge density decreases, and here two methyl groups, so charge density decreases more. That is, simply we can say that methanol carbonyl carbon charge density is very high and propanol carbonyl carbon charge density is the lowest. So from the reactivity concept we know that the more the charge density, the compound will be more reactive. As methanol carbonyl carbon charge density is very high, so this is more reactive, and here one methyl group charge density decreases, then this will come, and here two methyl groups charge density decreases a lot. That is why this is less reactive and methanol is more reactive towards nucleophile. Here nucleophile, that is, nucleophile will attack this carbonyl carbon very easily, then this carbonyl carbon, and then this carbonyl carbon. That is, this compound is more responsive towards nucleophile and this is less responsive to nucleophile, and this is moderately responsive towards nucleophile. So we can say that methanol is more reactive, then ethanol, and then propanone. This is all about reactivity of aldehydes and ketones. If this class benefits you a bit, please subscribe to the channel. No more today. Thank you very much.